in like a couple years. Just a couple weeks ago, we were going camping in Shenandoah, and I brought your book along to figure out what the heck I was supposed to be doing.
Oh, awesome. I hope it was understandable. I have
It
another
was
one coming up.
cloudy, but I still brought it with as my reference text.
That's awesome.
Oh, awesome. Awesome.
We sent
Super
you
useful.
a copy, right?
Yeah.
Yeah, okay. Yeah.
It's downstairs, or I'd like yank it off a shelf. But
That's great.
other shelf.
We should be live. Apparently the waveform has collapsed. So we've been observed. Here we are in this location.
I feel electric, like an electron that's been observed.
Yeah, exactly. Yeah. Could have been halfway across the universe, but we're right here. Everyone say hi to me, and then I will say hi to you. That's how this works.
Hi.
Hola.
Hey.
All right. Yeah. So the people in the chat. So you don't have to worry about the chat.
No.
But everyone is saying hello to us in the chat, and then in a second I will say hello back to all of them, as many of them as I can. Yamagashi-san is saying that we are not live, but I just answered your question, Yamagashi. So what does that mean? Ding.
That there was a delay between when they typed it and when it showed up.
Possibly. That we're not actually live, that there's some kind of relativistic time dilation going on here. I guess that's possible.
You're like all up in the physics today.
Yeah.
All sorts of physics things.
Oh, I know. Hello to Adam Synergy, Andy Cowley, Aaron C., Bob Moeller, David Dunn, David Fairweather, Dusty Reichman, Frank Tippin, Gina Rodkey, Giselle Sabarin, Grant Lanning, Ian Farquharon, Janelle Duncan, Johnny Zed, Julie Hammond, Cranides Channel, Larry Beckham, Luke Duke, Martin Bradshaw, Nancy Graziano, Neil Yu, Paranor, Pierre Von Obergen, Arjone, Scott Bragdon, Sergio Botero, Tom Van Scotter, Yamagashi-san, Yuval Litvin, and Zapvan. Hey, everyone. Welcome to the Weekly Space Hangout. October 23rd edition. And we'll start up the show in about 1 minute. So.
What will I do?
We've got the original Happy Podcast Day here, so it's good.
Have other people been doing Happy Podcast Day without me?
Yep. So I don't know.
I feel so loved.
Exactly. I don't know whether you should feel like whether you need to like send out some kind of copyright strike against us, or whether you should feel.
No,
honored.
it is a Creative Commons license everyone can use, or public domain. Even better, everyone should have a Happy Podcast Day whenever they have a podcast day.
As a hashtag.
Whenever you need a podcast
whenever you need
day,
a podcast day, it should be a happy one.
Yeah, exactly.
Yes. I felt little vibes the past couple Wednesdays. Just like, ooh, did someone have a Happy Podcast Day? I think they did. That's right.
All right, we're at the 5-minute mark. I'm going to put you all back into your boxes, and we will begin the show. So there's us. There's me. There's the rundown. Make sure everything is right. All right, here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, October 23rd. I'm Fraser Kane, publisher of Universe Today. This week, we are going to be talking about updating Planetary Protection, the first all-female spacewalk. Did an ancient supernova force humans to walk upright? The upcoming transit of Mercury and 3D printed meat on the International Space Station. And then, if time allows, whatever will occur to me. Joining me this week on my screen, we've got Dr. Kimberly Cartier. Kimberly.
Hello, Fraser. Happy Podcast Day, everyone.
We've also got, Nika Klimovich in Germany, as always, being the absolute trooper, getting up at like 2 a.m. to join us. Nika, welcome back.
Hello, Hangout community. Happy to be here.
I can only assume that he's somewhere in the United States. Dave Dickinson.
Hey there. Yes, I'm in Norfolk here. It's 8 p.m. here, so.
Right on. It's always a question of where's Dave now? How's the book going, Dave?
Pretty good, actually. The manuscript's going in next on Halloween next week, so I'm about 98. Actually, I could probably turn it in now if I absolutely had to. I'm in endnote and footnote hell right now, so which is its own special form of hell.
I'd better write my intro. I better get that done. I'll get on that. All right, so before we get on to the actual show, I would just like to give a gigantic reminder to everybody that if they want to be a member of this amazing community, go to the Weekly Space Hangout crew at wshcrew.space. They will set you up as an executive producer of the show. And that is just not, that's not like an empty title. That is literally, you can tell anyone you want that you're an executive producer of the Weekly Space Hangout. You can reach out to bring guests onto this show. And so I think it's, if you want to help make this show better, if there are certain guests that you want us to talk to, this is your chance. So go to wshcrew.space. And of course, a huge thank you to Nancy Graziano for doing so much production behind the scenes. Thanks to Susie Murph for helping keep the show on the rails. We really couldn't do the show without the both of you. So thanks, everybody. All right, let's get on to this week's special guest. And joining us from the Planetary Science Institute, we've got Dr. Aileen Yingst. Dr. Aileen, welcome to the Weekly Space Hangout.
Thank you very much. I'm glad to be here.
So the question I always ask, who are you and what do you do?
Well, you've already given my name. My name is Aileen Yingst. I am a planetary geologist. I am interested in rocks. I just happen to focus on the rocks on other planets. And I'm involved in several missions to bring that data back to Earth.
And which perhaps are some of those missions that people might have heard of?
So Opportunity, which we recently lost, and the Curiosity Mars rover. I am also involved with the recently funded Dragonfly mission and the soon-to-be launched Mars 2020 rover.
All right, so I want to just spend the entire hour talking about the Titan Dragonfly, but I'm going to resist that, obviously. So before we go to the Titan Dragonfly, I would love to hear just, you mentioned just sort of briefly before we went into this that your focus is on micromorphology, the sort of the smaller, the little rocks in these regions. So how do the rocks, especially the sort of the smallest features on Mars, compare to what we find here on Earth?
Similarities and differences, just exactly like you would expect. So if you pick up a handful of sand, you'll see the differences in each of those grains, sometimes color, sometimes shape, sometimes size. All of those things tell us something about the parent rock, the original rock that those little bits and pieces came off of. So on Mars, we expect to see grains that have been, kind of knocked around due to impact because the atmosphere is so thin. But what we were also seeing is grains and larger pebbles that have been rounded and smoothed by water action, significant water action. And you also see plenty of grains that have been blown around, knocked around, and changed by wind.
And
so very similar to what you'd expect to see on Earth in some ways.
But I know one of the issues that we have with here on Earth, we have so much weather, and we have the wind, we have the rain, we have all of these processes that are weathering down and smoothing out the smaller grains. And I know, say on Mars, you do have some of that wind. So if you had like a handful of Martian regolith and a handful of similar red Earth dirt, would you be able to tell the difference?
I think it would depend on where it came from. Remember that the surface of Mars has not always been the way it is now. And so a lot of the record that we see happened back when Mars had a lot more weathering that was occurring. Yes, you could tell the difference, but not by first glance, probably in some places. So there really are a lot of similarities, but there are compositional differences. You don't see the metamorphic rocks, for example, that you see on Earth. But it would be a struggle at first, probably, to tell the difference.
Actually, reading a book right now, and they're sort of talking about the formation of even just sand, that you won't get sand without quartz ending up in larger chunks of, I think, granite. Like there's some of the features that we see here that are very common actually, as you say, require this metamorphic process that requires intense weathering over long periods of time with large amounts of water to grind them down and to produce these kinds of materials. And in some of these other places, we just don't see that. And it would be interesting. We could do that as an experiment sometime. When we do bring that sample back from Mars, have different scientists try to just sort of guess which one is actually the regolith and which one is the simulant.
Well, you probably wouldn't see a whole lot of quartz in a Martian sample, but there are plenty of hard rocks and minerals that would survive for long periods of time. There are places on Earth that have basaltic sand. There are places on Mars. There are plenty of places on Mars that have sand-sized basalt.
So then let's sort of take this idea then and go to, for example, Titan. Titan shifts this whole idea of what a rock is. It's almost like the entire surface geology and liquid system has just been shifted one phase over. So you've got water ice acting like the rocks and the sand, and you've got methane acting like the liquid. So how does that change your job as a geologist?
You might be surprised at how little it changes my job. When I first started out in geology, one of the things I was most excited to learn was that water, liquid water, was a lava. Right? Technically, as far as a geologist is concerned, if you have a rock-forming mineral or a rock-forming substance and it is in its liquid form on the surface, it's a lava. And so making that jump to another planet it may not be as difficult as it sounds, because the laws of physics work everywhere, and solids and liquids and gases are what they are. You're just in a place where things are really super cold. And so, as you said, instead of water being, something we'd normally see in a lake on Titan, we think there are methane lakes, right? Because that's where the triple point exists at really, really cold temperatures. And that liquid is probably going to have some different properties. But when you look at the picture, the one set of pictures that we have from the surface of Titan from the Huygens probe, you see rocks that have been worn down by liquid. They look familiar.
And so, so those rocks, when you're looking at that landscape, those are blobs of water ice? Or are they actually rocks? Or is that still not entirely sure?
It's the same thing. Yeah, it's the same thing. You have a rock-forming mineral in its solid form. That's a rock.
Right.
We on Earth are more used to other rock-forming minerals forming rocks. But the universe is a very big place, and even the solar system is a really big place. And so calling ice a rock, sure, it's a rock-forming mineral in its solid form.
Right. And so then this idea of cryovolcanoes that we see on places like Enceladus and possibly Europa and possibly every icy object in the entire solar system, your knowledge of volcanoes works perfectly well to help understand that.
My beginning knowledge, how's that?
Yeah.
Right? Because there's always differences. There are always, you always have to keep yourself open to things that you wouldn't expect, and you have to be prepared to be humble.
So on that
in
note,
general, yeah.
There's a great question that came in from the chat. Ben Kalo asks, are there any rocks or minerals that we find on other worlds that can't form on Earth?
We have discovered, for example, certain combinations of minerals on the moon, for example, where we have plenty of samples brought back. Armalcolite, for example, is one of those things that was discovered on the moon, and it comes from the names Armstrong, Aldrin, and Collins for obvious reasons. So there are certain minerals that are much more likely to form, for example, in those in the temperature, pressure, gravity, tectonic existence that is the moon. I would hesitate to say you could never find certain things on this planet or that planet, but the conditions are ripe for armalcolite on the moon, and they are not on Earth.
Right. All right. So let's talk about Titan Dragonfly. This idea that at some point they're going to send a nuclear battery powered quadcopter to Titan. It's such a mind-bending idea. What will the mission do? What will it be looking for? What are the big questions that you're trying to answer?
Excuse me. Dragonfly is a reconnaissance mission, very much like the original Spirit and Opportunity rovers were for Mars. The beauty of Titan is that the atmosphere is thick enough that you can, and we have the technology now that we can send this beautiful octocopter to take off, go someplace else and land, and then take off again. So here on Titan, where we're not terribly familiar with the landscape, we have the ability to be mobile in this way rather than in the traditional way of a rover. So I mean, I can quote the goals and objectives, I suppose, but really the important thing here is reconnaissance. We have that one shot from the Huygens probe, and we want to know what Titan is all about. This is essentially a planet. It's with its own atmosphere and its own set of conditions that is unique and yet in some ways familiar. And so that makes it a really, really important data point for us to understand.
I mean, I think one thing that's really fascinating about Titan is how it really kind of crosses that line. I mean, on the one hand, it has this, a lot of things in common with some of those other ice worlds. Like it probably has a vast liquid ocean under the ice surface as well. But then on top of that, it's got this whole other cold environment with the liquid methane that falls. And then you've got these sort of organic materials that could be useful for life. And maybe there could be some kind of transportation, some kind of way that material gets inside and outside. Do you think that, this gives you an opportunity to sort of get a 2-for-1, right?
Right. So I think what you're referring to is on Earth, you have the cryo cycle and you have the water cycle and so on. One of the really important things for us to understand on Titan is there a cycle? What does that cycle look like? What cycles through? What contributes to that cycle? So, for example, there seems to be there's good evidence that an area called Sotra Facula is a cryovolcano, and it emits water, but it also has ammonium in it. We might be looking at a volcano that actually erupts a composition that includes paraffin wax, polyethylene. It's crazy. The chemistry out there is, to us, it's crazy. But then all of that stuff would then go into the atmosphere. Anything that comes out of a volcano is going to go into the atmosphere. It's going to become part of that cycle. So absolutely, that's something that is crucial for us to understand, to really understand Titan, to understand that cycle.
And I guess, part of the problem is that it's so far away. The timelines that you're looking at with this mission is a long time. I mean, best case scenario, when do we see pictures from the surface of Titan?
Best case scenario, you're probably looking at 14 years. And it's not just a question of trying to get to the outer solar system. It's also a question, once you get there, of how you're going to do operations. It's one of the reasons I was asked to be on the mission, because I have experience with that time delay of telling your avatar what you want it to do, and then sitting at home going, okay, here's what we're going to do for the next 3 days while it's doing its thing over here. So it's that combination. So it's going to be, I mean, the solar system is a lot bigger, I think, than those of us who grew up with Star Trek really internalize. It takes a long time to get out there.
Yeah. Arjone asks, what kind of experiment would you like to see done on Titan if you could add an experiment to the mission?
Oh, I'd add an arm in an instant. I'd add an arm with lots of instruments, and I'd dig in the soil. And
I know a country that likes to make robotic arms. So just talk to us in Canada. We got an arm for you. But yeah, so it's not currently planned to have any kind of way to reach out and grab things and munch on them.
Not to munch on them for sure. No.
What sort of range will it have? Will it be able to cover all of Titan, or will they have to pick a region and say, okay, it will only have this limited range?
Yeah, it'll have a limited range.
Okay.
Very much like the rovers that we have on Mars now.
That's very limited then.
Yeah, we're not flying across the planet, if that's what you're asking.
Yeah.
But part of that is safety, right? You don't want to get too far. You want to be able to always kind of be pointed in a way that you can talk to home base. So
all the site selection is probably going to be based on what Cassini and Huygens saw.
Yeah, that's the information that we have. That's all we have. So absolutely.
Wow. Absolutely fantastic. I know that, I can speak for our audience that is definitely one of the missions that they are most excited about. And I think there was a collective cheer from all of space fandom when that mission was approved. So I'm definitely looking forward to it. Well, Aileen, thank you so much for taking the time to chat with us today. If people want to sort of find out more about what you're working on, what's the best place to go?
If you go to the PSI website, that's www.psi.edu, and look under staff, you'll find me, on the last page, because that's what happens when your last name is Yingst. And you can, that's a very professional looking page, but there's also a nice little link there to a personal page as well. So people are welcome to come see me.
Excellent. Well, again, congratulations on getting the mission chosen and funded by NASA, and I really look forward to the science results. We'll talk to you in 14 years. These first pictures come out.
You have to hurry up. We're getting old. So.
Yeah, exactly. Yeah. Hopefully, I'll still be doing this job in 14 years.
14 years.
Yeah, exactly. Thank you so much for taking the time to chat with us today.
Thanks very much.
All right, let's move on to the space.
I just have one comment before we move on.
Yep.
Ice is totally a mineral, and the geology community spoke this year, and it won the Mineral Cup on Twitter, beat out all those traditional minerals, and it was ice. Ice won. It was the best mineral this year. Totally a mineral.
Water ice.
Totally a rock. Water, ice, rock.
Okay, water ice, because...
Mm-hmm. Water ice.
Other...
I asked. I was... Yeah, it was a little bit on
Wait a second. Hold on a second.
What?
Am I missing some kind of controversy in the geology community about a certain other kinds of ice? What?
Well,
if you freeze something, it's ice.
Yeah. But no, water ice won the Mineral Cup this year. So totally a rock.
Totally a rock. Nice.
I agree.
There we go. And it's got it won the
popular vote.
It's true. You got to differentiate, because there's CO2 ice and methane ice and stuff, but water ice, what we're most familiar with.
Kimberly, let's talk about planetary protection. When we go to Titan, and
speaking of Titan, and possible transports, exactly, things that are important for life. So NASA's policies for protecting the places that it goes from us, bringing Earth life there, and then if it ever brings stuff back, protecting us from whatever the heck bacteria might already be there. Those policies are really, really old. They were created before the Apollo moon landing in their original form, and they haven't substantially changed all that much in the past 50 some years. But in the meantime, we've learned so much more about what the moon is like, what Mars is like, what Europa and Titan and Enceladus are like, and all these other places that may have environments that are hospitable towards life, our life or life that developed there. And so early last year, the National Academies and the NASA Advisory Council said, hey, NASA, you gotta fix this problem. You're like 50 years behind the curve here. So earlier this year, an independent review board met and evaluated every single line in NASA's Planetary Protection guidelines. It's a pretty big set of rules. And just last week on Friday, the review board released its set of recommendations on how NASA can bring its planetary protection protocols into the 21st century, and all of the 80 odd recommendations and findings that it needs to do in order to actually meet its goals.
If you were to like encapsulate it in like a couple of words, like mine was like loosen up, man.
Yeah, I would say the words that I would use are keep up with the times.
Yeah.
I think that the two biggest recommendations that the committee came back with, which I wholeheartedly support, and pretty much everyone I've talked to is totally on board with, are you need to figure out what planetary protection standards, what level of sterilization that a mission needs for its goals early in the mission's life. So not, a year before it launches, not right before it does its final tests.
Or not after it's been orbiting Saturn for 10 years and now it's reached the end of its life.
Landed on Mars within 50 miles of a pool of water.
Right.
Not that that's ever happened.
Yeah.
But in the actual planning and development stages of a mission, figure out what the actual standards that mission needs to meet what they are, so that those can essentially be built into a mission from the ground up, which kind of stunned me that wasn't already what they were doing.
Yeah.
Like, why wouldn't you do that? But that was a very key finding. And then the second really big finding, which is really important, is to reevaluate these rules at least twice a decade. Like every 5 years, give them another look and update them with the latest science.
Yeah.
And they broke it down into all sorts of different categories, including the private sector, the moon and Mars, and how we should maybe rethink some of those things, ocean world, human exploration, obviously. It's a very comprehensive document and overall has gotten very positive reception.
Well, and I think that's part of the issue is it's not just NASA now. When you look at, say, SpaceX planning to build a city on Mars within 5 years from now, to begin the construction of the city on Mars, that and they won't necessarily have the same kinds of constraints. So it does make sense to try and place some kind of limits even for private companies. When you think about people planning to mine asteroids, people to manufacture things in space, people to potentially going to other places in the solar system.
So I think one thing that many people don't realize as far as the SpaceX goals for putting a human colony on Mars is that if SpaceX did so, it would actually violate international treaty, because right now how Mars is categorized under planetary protection says no humans are allowed on Mars. That's way too much contamination. You can't do that, and that's an internationally ratified treaty. So if SpaceX were to do that before these rules are updated, the U.S. would actually be liable for whatever SpaceX does because it's a U.S.-based company.
Right.
Part of the recommendations include giving a more nuanced look at Mars's surface. We know that some places on Mars really aren't good for life at all. Those don't need to have such stringent rules. Some places might still be hospitable for life for any bacteria that we bring there. And so those should still stay under very strict rules, and maybe we can reevaluate, pick and choose places where we might be able to loosen some of those restrictions. Maybe land some humans there one day. And, figure out what happens if some company, for example, sneaks some tardigrades on their mission and it crash lands on the moon. How do you deal with that?
Yeah.
Who gets punished for that? Is that a violation?
Got punished.
How do you do that?
Yeah, Israel did that earlier this year. So.
Yeah, I'm speaking, of course, of the Space IL Beresheet lander, which crash landed on the moon a couple months ago, and then later it was revealed that there was a cache of DNA samples and dehydrated tardigrades in the lunar library that was on that mission. Nobody knew ahead of time. The launch provider certainly didn't know. The people who issued the launch license certainly didn't know. It's not illegal, but the fact that nobody knew about it ahead of time, like, really got on people's nerves, made people very angry that no one knew.
Well, maybe this
so what
is
do you
what
do in that
Space Force
situation?
will be for.
I hope not. I hope not. Yeah. It talked about, what do you do in those sorts of situations? Let's figure that out before it happens again.
Yeah. So, I mean, that idea of planning out the planetary protection status of your entire spacecraft before you even begin to plan out its trajectories and construct the equipment on it, it's interesting to me that was not necessarily a big consideration. I mean, they always knew that they would have to put it into the clean room or that they would have to disinfect the spacecraft. But
it's not just that. It's also to what degree you have to disinfect it, to what degree do you have to sterilize it, what standards do you have to meet. And also, one of the things where you said a good summary is loosen up. And that's very true. It says we recommend that you allow for some creative solutions to these problems. I mean, a lot of the standards are based on 1960s technology and 1970s technology in order to sterilize a piece of equipment.
And even just understanding.
Space sterilizes things all the time.
Well, remember that the astronauts, when they brought them back from the moon, they kept them in quarantine for weeks because they thought they might have brought back, they could have brought something back from space. So we have a tremendous amount of knowledge now, very specific knowledge about how these things handle being in space and how they come home and re-enter through the atmosphere and the radiation environment and all that.
That was the best that we knew at the time. We treated it with the best knowledge we had at the time. Now we have more knowledge, better knowledge. A craft that spends years in space getting to Titan will have a harsher radiation environment and kill off more of the bacteria in transit than something that's going to the moon in a week.
In the chat, Pierre Van Obergen is saying, explain why not contaminate. Is there some reason other than finding real local form of life? What is the main reason why that scientists should be concerned about contamination?
Well, one of our major questions is, are we alone? And how did life actually develop? And we have exactly one data point for that right now, and that's here on Earth. And the only way we can actually figure out, can life develop under other situations? What are the actual limits for this? Is to examine life that has developed under other conditions. And if we bring pieces of ourselves to these places, it could potentially wipe out any other life that already exists there. Or it could essentially contaminate those experiments. Plus, it's polite to not destroy an environment when you go visit it for the first time. Humans have traditionally not been so good at that, and we probably don't want to keep doing that in space.
Yeah, I mean, if you go and you take a filthy spacecraft to a place on Mars and it digs around, and we know that we have life forms here on Earth that will do a great job of colonizing some environments on Mars. Like this has now been demonstrated that there are cyanobacteria that are good to go to just send us in, Chief. We're ready. And
so that's another thing that NASA is probably going to want to do. I mean, we've brought bacteria to other places. Certainly, many of the things that have crashed on Mars and on Venus and on the moon haven't been properly sterilized for whatever environment. And so we should go back and check and see what was the actual level of contamination there. Did it make a difference or not? And let's, fold that into our policies.
Yeah, it's like, imagine you digging around in Mars and you're like, wow, more cyanobacteria, more Earth cyanobacteria. Everywhere we look,
looks just like what we see on Earth.
It's exactly like what
funny.
We see on Earth. That's so weird.
Yeah.
And the reality is that's because you brought it.
Yeah, and I think a really positive side effect for this whole set of modernization that it's going to be doing is it's going to significantly lower the burden on many small missions, many exploratory missions, low budget missions, CubeSats, things like that don't have a lot of money to work with to get their mission off the ground, literally. The actual process of sterilizing and decontaminating a spacecraft prior to launch to the level that's needed for going to Mars, that's a huge chunk of money.
Yep.
And a huge chunk of time as well.
That was my question.
So
basically, yeah.
So
I was wondering who's gonna do it. Who's gonna check the standards are met for these small companies, you know?
That's one of the things that needs to be put in place. We don't have rules for that right now. So that was one of a big recommendation from the review board is we got to have some sort of oversight, and who's going to do that?
Yeah. Well, before we move on, you propose that we should quickly make a mention of the historic spacewalk.
Yes. This has been 54 years in the making. 221 spacewalks later, 2 women were the only spacewalkers. Yay! All women spacewalk. It was awesome. Great milestone, great historical event. Yay!
Jessica Meir, she's native of my Aroostook County, Maine. She's the first astronaut we've had from Aroostook County, Maine.
That's awesome.
As well. Yeah. So.
Woohoo!
Wish I could say I knew her, but I don't.
Oh.
And of course, we were talking about this before the show that Alexei Leonov, the first person to spacewalk, passed away
just 1 week before
just
this
a week
happened.
Before, yeah.
During a spacewalk, the ISS spacewalk.
Oh, he passed away during a spacewalk.
Well, it was the same day. I don't know if it was right exactly. There was an ISS spacewalk that same day, like 6 hours long. So
yeah.
Yeah. Anyway, this was a great event. I'm glad that they had the right spacesuits this time.
Ones that
Good
fit.
job. And I hope to see many more of these in the future. I will point out that there have only been 15 women to spacewalk ever out of 221 spacewalk events. So I'm hoping that there will be an increasing number of those as time goes on.
And on the moon. How about like any women walking on the moon?
Artemis?
Yeah.
I suppose.
That's the plan. Nika, let's talk about 3D
Anyway, that was my yay.
Space meat.
Go women spacewalkers.
Yay. Nika, let's
Totally
talk about 3D printed space meat.
So, few episodes earlier, we talked about food demand on Mars. So maybe that is one possible solution. So there was an experiment to print meat on board the International Space Station using magnetic bioprinter called Organout. Okay. So the 3D printer works similar to the standard printers that you have in the offices, where you print your letters layer by layer. And in the 3D printing, you have some kind of injection head with the material flowing, and then it shapes and like throws this material layer by layer, developing a structure of your desired sample, yeah. And some of the bioprinters and the standard printers, they use this technology, but this experiment was a little bit different. They use a little bit different technology. So what they do, they first create 3D magnetic structure, like magnetic form, and by using magnetic nanoparticles, and then they throw the cells inside this 3D form. Yeah.
Right.
And then these cells, they interact with other cells, and at some point they grow together, like typically within 24 hours. So the experiment was conducted in the Russian segment of ISS. And the cow, rabbit, and fish sample pieces were printed using the corresponding cells. And I think it's like crucial to adapt and improve this technology. And it's very good that the space is helping to do it. It's crucial because to produce 1 kilogram of beef, for example, you require 15,000 liters of water, land with grass, a cow, you need to kill the cow, and then considering the increase in food demand and the associated effects on the environment, then it is kind of a good thing to have printed meat by copying the cells.
Yeah, I mean, there's no way. I mean, if people are going to be in space and they're going to want to eat meat, there is no way they're going to be able to have it coming from an actual animal. I mean, can you imagine an astronaut cow floating around in your space station, chewing grass and pooping and like, you know,
or on
mooing
Mars,
and
or
floating
on Moon,
by
or anywhere.
Yeah, no,
space cowboys are never going to be a thing.
Space cowboys, yeah, no,
Nope.
you're gonna be, and so this, I mean, this technology, if it can work. So did you get the impression that being in microgravity helps make the lattice, helps make that
Totally.
structure of the burger itself, or of the meat that they
Totally.
made?
That is exactly why they are testing at space. So the big advantage of microgravity for these technologies in bioprinting especially, first is that the cells grow better in the microgravity. Second is that the technology itself, when you do the shape, you know, under the Earth's conditions, under the Earth's gravity, it kind of collapses, like all the cells like basically go to the bottom, and the structure doesn't doesn't help the structure basically of the required tissue, and microgravity helps to achieve it. So you can shape whatever you need and it will stay at the places where you put it basically, and that is really a big advantage. And there was a third one that like tubular forms, like blood vessels, they are better formed also in microgravity. Not sure why.
Wow. So I mean, it's not only is it going to be the way that astronauts are going to get some of their protein sources, but in fact, it looks like it could be easier to grow them in space than to grow them down on Earth, which is a real advantage.
Yeah, basically what they want to do, they started with printing the organs, human organs, or the mouse and human organs, or basically pieces of it. And the idea also behind the NASA program, they have similar one. They want to print organs and like basically kind of held it for a while in space and then bring them to Earth. Of course, it will take many years for the research, or for example, for the missions, when you go to Mars, you don't have a possibility to basically have a doctor and get some skin from somebody else. So the ESA, for example, is also working on skin 3D printing and bone 3D printing. So if something will happen, you can print basically the skin and basically doctor yourself.
That's fantastic. That's great. I mean, I would eat a 3D printed space burger. I'd try it. And
there were
like made of rhinoceros, or something, if it's 3D printed, it doesn't matter, right?
Actually not.
So
I think anyone who gets a bit squeamish about thinking about 3D printed meat and is that going to be good or bad has obviously never tried the dehydrated astronaut food that they currently
it's
provide.
Already terrible.
It's already really bad.
Yeah.
No one wants to eat that. 3D printed meat could be a huge improvement.
Yeah. Oh, fantastic. Well, that's good news. So they won't have to eat crickets. They could be able to eat that 3D printed space burgers. Dave Dickinson, what have you got for us?
Well, I was reading, there was a study a few months ago in Journal of Geology from the University of Kansas that came out, and I saw it make the rounds, and I decided it was talking about whether a supernova or several supernovae nearby, ancient supernova, caused humans to become bipedal millions of years ago, walking upright, of course. And at first I was kind of like, what's even is the mechanism on that? And I hadn't seen the story go around. You're kind of like, how do you go from supernova to evolution and walking upright? So I decided I would look into it and actually read to see if there was anything. It was kind of intriguing. It's kind of one of those things, still a little skeptical because it takes several logical leaps to get from one to the other, but it's an intriguing idea. The idea is supernova goes off by Earth about 100, 150 light years away, 3 million, 6 million years ago. this showers the upper atmosphere with cosmic rays, highly energetic particles, things that spark terrestrial wildfires. Now we know terrestrial wildfires are the biggest natural cause of forest fires, or lightning strikes rather, that are sparked by cosmic rays. This upsurge, and they see this in the record, and that's what they're basing this on. They see the isotope of iron-60, which they know is seeded by supernova. And they also see a lot of carbon in the record at that time, meaning that there was a lot of forest being burned and things like that. This would accelerate the growth of savanna in place of forest. Now, if you're on the savanna, they know one of the reasons we probably evolved walking upright, meaning we were selected for hunting on the savanna. You think you have a better range of vision if you can stand upright and you're looking from, say, 5 or 6 feet. I noticed this when I was walking my dog, that when you're walking a dog in the neighborhood, I tended to see things before the dog would see things. And you think if you're hunting on the savanna, you have that height advantage on the dog, just enough that you can see a few feet, especially out over the tall grass. That definitely, those were the people that had that random mutation. They know there's, I think it's chromosome 17, that there is a mutation on chromosome 17 in humans that caused us to walk upright. And that one random mutation, you have it, you're a better hunter, you're going to leave offspring because, so that was the mechanism they had. And it's interesting because they see some of these things. I talked to some of the researchers, and of course I want to know, it's like, well, is there any smoking gun supernova out there they could point at? And it's really hard to tell 3 million years ago because all the stars are moving around the galaxy. We're going around once every 250 million years. Anything that was nearby to us 3 million to 6 million years ago. And there were some objections I found to this too, because they're saying, well, it wasn't something humans being bipedal and walking upright didn't happen all of a sudden. It happened over several million years, something you would think would be less likely if there was a certain triggering event. And another thing they see is that we live in what's called the local bubble, which is an area of the interstellar medium they know was carved out by super ancient supernova millions of years ago. So it's one of those things. It's interesting to think that there was this cause and effect out there that might have had a impact on evolution, on human evolution out there. And these kind of things might have gone on several times. I actually included something I'm working on in my new book for the post I did on Universe Today, where you look at, I always wonder, where are the nearest supernova right now? And they usually peg I think it was the earlier Universe Today article I cited, the kill zone for supernova at 25 light years out. There are no stars that are, the nearest ones are, I think there's one in Perseus, like GK Perseus, 150. Betelgeuse, if we're going with I heard you and Pamela talk about the pronunciation for Betelgeuse. I'm going to say Betelgeuse. I agree with Pamela as well, without getting into a long dissertation on Arabic pronunciations.
I have no opinion.
I've had that same argument with people at star parties. There are, if you go through this book here, you can find up to 6 different pronunciations for Betelgeuse. I still like Betelgeuse. So
what are some of the other ones for the people over here?
Like Betelgeuse, Betelgeuse. I know I took Arabic and I know the G is a guttural, so it should be like sound to it if it's pronounced, because most of the stars have Arabic sounding names. But and especially since the movie Betelgeuse came out, Americans have always said Betelgeuse, and I know what star you're talking about if you say Betelgeuse. So anyway, that is a close. I think it's in the 700 light year range. Another one that could go supernova. Incidentally, if Betelgeuse goes supernova, I hope it goes supernova when the sun isn't nearby, so it's not on the other side of the sun. I believe the sun is nearby that area in the summertime, right. So it's better if it goes off Orion and Betelgeuse is up in the wintertime. Think of how the irony if Betelgeuse went supernova and it was on the other side of the sun,
right,
at that time. After so
it would be visible in the daytime, except it's behind the sun.
The sun,
yeah.
It's like come on, it's like we haven't had. Kepler's supernova, I think 1604 was the last one, right before the age of the telescope. Galileo started observing 1610 and doing observations. So we haven't had a galactic supernova a naked-eye one. We had one, say naked eye, we had one in the Large Magellanic Cloud in the 80s.
89.
That wasn't,
yeah,
that wasn't in our galaxy.
Yeah, and in theory, there should be one going off every 100 years or so, and yet we haven't had one, as you said, since Kepler.
One of the papers I dug up for the article is by the same author that did this one on terrestrial supernovas causing terrestrial fires. An interesting statistic. He said, on average, we have a supernova in the kill zone not quite every billion, it's like 800 million years. So we probably had a few over the history of the lifespan of the Earth. The Earth's 4.some billion.
And so some of those could have explained some of the mass extinctions in the past.
Yeah. And if we had one within 100, 200 light years, we might be able to test this theory of upticks, cosmic rays causing lightning strikes and upticks in lightning strikes. We may see that impact if we happen to have one. There are a couple that are within the few hundred light year range that this paper cites. So it could be an interesting time.
Before we wrap up, I'm not sure you're going to be back in time, so we should remind people that they're going to be able to see a rare event in just a couple of weeks.
Yeah, semi-rare happens. We had one in 2016 where Mercury transits in front of the face of the sun. That's on November 11th next month, just coming up in a few weeks. We're going to see it here in its entirety. You're going to see it up there with Mercury the sun rising while Mercury's in the transit. And over in Europe, they're going to see it while Mercury. That's going to be interesting because you'll be able to photograph it with foreground, maybe a silhouette of a mountain or a tree or a church with something like that. Now, this versus an eclipse or Venus where you could just kind of project it and see it, you're going to need to use something filtered, all the same safety precautions as a total or partial solar eclipse, but you're going to have some magnification because Mercury's not quite big enough to resolve the dot with the naked eye. One thing I built with eclipse glasses, and I used during the 2017 eclipse, this is a T-box. These are a pair of solar eclipse glasses on the front, and it goes right on the binoculars.
Oh, awesome.
So it's, I have a YouTube video up I did right before the 2017 eclipse, so you can actually use your binoculars to, that's one way. If you have one of these, hydrogen alpha scope, these work great. I'll probably be showing people out on the sidewalk out here of the day of the transit. Or I can also put a white light filter on that telescope back there. But, it's kind of neat. It's about 5 hours long. Yep. Mercury will look like just a little dot, going out in front. I know Virtual Telescope Project astronomer Gianluca Massi, he's going to be there'll probably be several live streams.
Yeah, we may live stream it. We'll see what kind of gear we can get set up to be able to do it. But still, but we're not going to see it again until like 2032. So
yeah, they're on average they're about once a decade, but we're going to have kind of a break. I think if you average it out through the 21st century, there's about 7 or 8, maybe 9 transits. Yeah. But I think it's this one we're going to be a while. That's how I imaged it. This is also in the book too. When I was in Spain, because all I had was a pair of binoculars and a tripod. So I just projected it back onto a piece of paper through these binoculars. I mean, now you wouldn't want to use these binoculars for very long to do that kind of thing because you don't want to melt the optics. These are a pair of image stabilized binoculars that are like over $1,000. So I wouldn't want to use those to image the sun for more than like a minute or two.
What's that wonderful book that you're talking about there?
This is the Universe Today Complete Guide to Observing the Cosmos.
Wow.
And book 2 is coming out. I've been working on, here's all the rough star maps that I've been crossing my eyes doing. This next one is going to be very graphics heavy. This is going to cover all the top deep sky objects, northern and southern hemisphere.
Yeah, the goal here is to give people a practical book for being able to figure out what's up in the sky for them that night. So stay tuned. Back to work, Dave.
Yeah.
All right. Well, you're on my screen right now. Actually, you know what? I'm going to say one quick thing before we go, which was, I think last week we talked about the fact that SpaceX had put in an application to launch another 30,000 satellites as part of the Starlink constellation. So now the total number of satellites they plan to launch is 42,000 satellites, which is well over 10 times, 30 times as many satellites.
It's so many satellites.
So many satellites. Now it's possible that that's actually not their plan, that their plan is to try to sort of dominate the spectrum, and so they're putting in all of these satellites up there. So we're still going to have to wait and see what actually happens and how many satellites happen. But this week, actually yesterday, Elon Musk tweeted via Starlink. So he was able to actually send a message through the Starlink constellation, just the first 60. So he apparently has a terminal that he can use from his house and to be able to communicate to the internet via the Starlink constellation. And it worked. So Glenn Shotwell from SpaceX announced that they're accelerating their plans to actually build the Starlink constellation. We're going to see the next launch probably in just a few weeks now, probably 5 or 6 launches over the next few months, and that we will see a operational Starlink service in the mid 2020. So we're actually probably less than a year away from being able to buy your satellite internet. And on the one hand, I can't stand the idea of having all of these satellites pass through all of the photography and the poor astronomers. And on the other hand, I think it's pretty cool to be able to get high-speed internet from anywhere in Canada and the US for now. That's all I'm waiting for to buy a piece of property outside of the city that I live in is internet, right? I do everything on the internet. So if I can do that, that would be pretty great.
I think we also have to consider the fact that all these thousands of satellites up there also have to deal with all the satellites that are already up there, that are doing very critical science. I think we all might remember earlier this year a near miss with one of Europe's satellites, and Europe had to suspend that satellite's science investigations in order to navigate around SpaceX.
This is a big
Starlink satellite,
be a big problem.
It's going to be a huge problem. It's more than just like these satellites messing up our ground observations, which plenty of astronomers are really annoyed with. But it's actually could be creating a lot of hazards up in space, which is another area where we have very few regulations on how to deal with that.
The regulation. The regulations is desperately needed for the maneuvering. So it's just the more the satellites there in the space, the worse it is for everybody. So, and there is nothing in place currently, no rules.
I think one of the European people that I talked to said that it was like the Wild West up there. You make your own rules as you go.
The first OneWeb constellation satellite's going to go up in November 19th too. So they're going to be joining. There's other companies that want to do this sort of constellation, but they're doing another launch here, or they're doing their first batch next month. So,
as I've said as well, if this actually works and this is able to provide internet to of undersea cable through sensitive marine environments and dig, and so it's just like it's a mess. And people need to think this through more carefully so that we have a solution that minimizes the impact on the environment, minimizes the chance of space junk, and maximizes the amount of access that we all get for the internet. So
they tried to do it with Iridium though too, and those became kind of just a niche application. Those were originally supposed to with satellite phones, but satellite phones never really caught on.
No, this is a whole different technology though. So because
they're
close and there's a million of them, or
it's too bad they
42,000 of them.
It's too bad they couldn't get them down to like CubeSat or WaferSat size or something.
They're pretty close.
Yeah, I think these are the ones that SpaceX are launching. They're more like small piano size, I think. I don't think they're quite CubeSat.
No, but they are fairly small. But like I said, I mean, I think all we can say is more work is needed to figure this out.
It might have been nice if they had figured that out ahead of time.
Yep.
Now we're
only then. I think everybody has to work together because it's not only SpaceX. It's like everybody. The idea is great. It's amazing. You can do a lot with it. So just like some kind of international talk should be on that topic, basically.
Well, I'm sure that this will be that this will increase the urgency of this issue as more and more of these satellites go up. All right, well, we've reached the end of our show. Nika, you're on my screen. Where can people find out more?
Twitter. I am on Twitter. Veronica Space. And I am like slowly posting things in there.
Yeah, you don't actually have to post anything, to Twitter. You just, as long as you've got, contact information, then people can find out about you. So don't worry about it. Don't feel like you need to, there's much better uses of your time than being on Twitter.
I already posted that.
Oh, well, there you go then. Yeah.
That we go on a talk Weekly Space Hangout. So
that's awesome. All right, David.
I'm still freelancing for Sky and Telescope, Universe Today, and working on my next book and by my last book. And the new one is up for pre-order too. I noticed on Amazon. So
and if
it's not coming out till July, but
if people want to find you,
at Astro Guys with the Z on Twitter. That's where I'm across all the things, but Twitter's where I'm the most active. So that's probably where I'll see you if you follow me. I'm more likely to retweet you or message you or stuff like that. So.
Kimberly.
Oh, I am always on Twitter, apparently, at AstroKimCartier, and at eos.org, where you can find all my writing. And I got an Instagram, and I do stuff there, but it's not really space. So.
But what is a thing that you worked on most recently? Did you do an article about the planetary protection?
I did a very in-depth article about the planetary protection. I spoke with a lot of astrobiologists and planetary scientists about, do you think this is enough? Are they missing stuff? They were missing some stuff. So it was a very interesting conversation to see the reactions from the actual people who this will affect.
Terrific.
And I just wrote an article about a geode that can fit a human inside of it. It's so big.
Sorry, a what?
A geode, like those
geode,
pretty things,
okay.
like you have on your desk as like a little paperweight, but it can fit several grown humans inside of it.
Wow.
And how does it get that big? I don't know. You might have to read about it.
That sounds awesome. All right. Of course, you can find me at Universe Today on all the things. I'm going to put everybody up here on the screen. There we all are. We've reached the end of our show. Thank you to our special guest. Thank you to all of my co-hosts. Thanks to all the moderators. And, of course, all of the members of the Weekly Space Hangout crew. We couldn't do this without you. Thanks, everyone, for watching us this week. I hope you've been enjoying the new format as we've been moving forward. And that is all thanks to Nancy Graziano for all of her hard work. So we really appreciate, there you go, all of the effort and cat herding that you have been going through. We will see all of you next week. And now the uncomfortable cut.